Alright, a little bit out of order, but we're going to solve rational equations and see what happens here. So, a long time ago, you were solving some equations, and they had some fractions, and maybe you would distribute here and here, and it just got to be a mess. So, we're not going to do that. What we're going to do is identify what can I multiply this whole thing by to clear out these fractions. So, we're looking for the least common multiple. And that number happens to be 6. So you're going to multiply the whole way over. And I do have an extra term in here, the minus 4. So we have to distribute that in 3 places. So half of 6 is 3. So now it turns into 3x plus 5 minus 6 times 4 is 24. Last I checked. That part hasn't changed. How we're doing all this? Changed a whole bunch. On this side, 6 divided by 3 is 2. And 2x minus 1. Okay, so this is really important into dealing with these rational functions and equations that we're about to deal with, because we don't want them to be fractions. We don't care for that at all. So we're going to distribute 3x plus 15 minus 24. Let's clean that up. 3x minus 9 equals 4x minus 2. Alright, not too shabby. We're going to subtract 3x. And add 2 all at the same time. So we got x equals negative 7. Right, but the important thing was least common multiple. Least common multiple is what we're after. That way, in our second line, we don't have any fractions at all. That's the goal. That's what we're going to try. Let's see how it works. All right, remember, that's what we're going to try. So it all starts with the decision that we're going to try this out. So here we are. So in the denominator, see an x minus 2, x minus 1, and then they repeat over here, so that's cool. That means I just multiply this by x minus 2 and x minus 1. As I distribute, I'm going to cancel out my x minus 2's. So that means the first term that I'll have is 3 times x minus 1 equals, as I distribute, the x minus 1's are going to cancel. So I'm going to get 1 times x minus 2. Now that 1 doesn't seem very important right now, so don't worry about it. But when we get to a minus problem or different things happen, that might be something that's important to us. And in the last one, we're going to cancel out the x minus 1 and the x minus 2 with these guys over here. So we get just plus 7. And so it started off looking like a very impressive, intimidating problem. But as soon as we know what to do with it, we're in pretty good shape. Alright. A lot of distributing going on, lots of arrows. So 3x minus 3, x minus 2 plus 7. These guys go together, so x plus 5, 3x minus 3. Getting pretty close to subtract the x, so we're going to get the 2x. And we're going to add the 3 to get the 8. So x turns out to be 4. Not too shabby. Alright, so we're doing pretty good with that. So important thing is looking at all those denominators to find the least common multiple. When it was a plain old number, not too bad. Hopefully you find that this won't be awful. It's manageable. We can do this. Alright, next one we have is I see an x minus 1. This one's over 1, so that doesn't really hurt anything. And an x minus 1, so we're multiplied by x minus 1. Yeah, I put it on the other side this time. You know what I mean? You just deal with it. That's what happens sometimes. So this is going to cancel. I get 3x plus 2 times x minus 1, because there was no denominator to cancel it out. And it equals, here it cancels out, 3. Again, it looked a little bit different. It presented a little bit different, but extremely manageable. Alright, distribute 3x plus 2x minus 2 equals 3. I got 5x. We're going to add this guy over. So that makes 5. X turns out to be 1 when you divide by 5. Alright, and we are just killing it here. Alright, and our next problem, this is where things get a little bit hairier. Notice this last one here, x squared minus 1, that should be x plus 1 and x minus 1. But it's not. But to identify the least common, least common multiple, we want to make sure everything's factored out to see what's already in common. So x plus 1 and x minus 1, that's what we're going to multiply by. So we'll get, after we distribute, let's pick a beautiful color here. How about this fuchsia? Alright, so we're going to distribute all this stuff, but the x plus 1s, they cancel out. So I have 4 times x minus 1. I have negative 1, and the x minus 1s cancel, so I have x plus 1, and it equals, both of these guys cancel out, so plain old 3. So it went from pretty complex, a lot of stuff going on, to not too shabby. Alright, here we go. 4x minus 4, distribute that negative, minus x minus 1 equals 3. So this is the place to be super duper careful, is distributing this negative. That's why up here I tied those things together. What do we got? We got 3x, we got minus 5 equals 3, and now you're thinking, oh no, I messed something up because 8's not divisible by 3. Well, guess what? Just like we're learning now, things aren't always exactly the way we want them to be. So that is exactly what we're going to get, 8 thirds, 8 thirds. So if it's not already factored, we're going to factor it to find that least common multiple. Alright, then we backtrack just a little bit here. We are going to cross multiply. This is kind of a blast from the past. We have two fractions that equal to each other. So we got 2 times 2x minus 1. I know you guys are saying, why did you just make it 4x minus 2? Well, there, I did, okay? Alright, and we got 5 times x plus 4. Yeah, I said I would do that, right? So 5x plus 20. Here we go. And now we're ready to solve. So I'm going to subtract my 4x. So that's going to give me 1. While I'm doing that, I'm going to subtract 20. So x is negative 22. Alright. So notice the difference. We are one fraction set equal to another fraction. No point in multiplying by a whole bunch of stuff. But by all means, if you multiply by the least common multiple, this is exactly what you would get anyway. Okay, but I want you to work smarter instead of so hard. Alright, if it is equal to 0, remember these are over 1. Now you're going to cross multiply, which means you have 0 times the denominator, which means all you have to do is x plus 4 equals 0. And then when we do the same thing here, right, these guys are going to go away. So we're going to get x squared plus 6x minus 8 equals 0. Now one of these is super easy to solve. The other one is another blast from the past. You guessed this one, super easy. Negative 4, final answer. That's it. Now the other one, we're just racking our brain. What are the factors of 8 that subtract to give me 6? Well, 1 and 8, no, that's 7. 2 and 4, nope, that's 2. Alright, so that's not going to happen. So it's go time now. We're going to go the whole way to complete the square, because if I know you guys at all, you'd rather do that, since b is even especially, instead of the quadratic formula. Remember, half of 6 is 3. It was positive, so we're going to keep it that way. Squared is 9, so this equals 17. Bada boom, here goes the square root to fix that. Then we're going to subtract the 3. Final answer, x equals negative 3 plus or minus the square root of 17. And that's how it works. Alright, so since we're dealing with some quadratics, you got to keep a hold of all those old things we talked about. Quadratic formula, complete the square, and of course factoring. We've been using that this chapter. Alright, don't be the same, be better. Trying to deal with this the way it is. So any questions you have, please throw them on here. That way I know how to help you any further.